We are going to discuss some important term like what will be the power of a language, power of language. The first thing that there will be no negative power, or it will start with 0. Suppose we have L1 language power 0, which will be equals to epsilon. L1 power 1 will be equals to L1. L1 power 2 will be equals to L1 dot L1. L1 power 3 will be equals to L1 dot L1 power 2. We can write like this also, or we can write like this also, L1 power 2 dot L1, or we can write like this also, L1 dot L1 dot L1. Suppose we have L is equals to AB, BA, then what will be the L square? It will be AB, 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 BA, concatenation of AB dot AB and concatenation AB with BA. In the same way, BA, AB and BA, BA. So suppose we have any string omega, then which belongs to L to the power n if and only if W comes to n times. But one more important thing is here also, that it can epsilon also belongs to L. Epsilon also belongs to any language, so it will always be less than n times, because language if contain epsilon, so it may be less than or equals to n. So suppose if we have but one more important term, that AB BA does not belongs to L cube if we talk about this L. If this language is equals to ABBA and we want to write ABBA is equals to L cube, that it does not exist. Why? Because in this language we don't have epsilon. But if we have L is equals to L is equals to AB BA epsilon, then AB BA belongs to L to the power q, because here epsilon is present. That's why the same thing I want to say here, that its length should be less than or equals to n time because of epsilon. I hope this will be clear from here. Or in the same way, we can write like this also, AB BA belongs to L to the power n, and n always greater than or equals to 3. Now come to the next thing, that star closure of L. What it will be? L star is equals to L to the power 0 union L to the power 1 union L to the power 2 and up to infinite. And what will be the positive closure of L? L plus equals to L to the power 1 union L to the power 2 union L to the power 3 and up to epsilon. In positive closure, epsilon will not come, so we can say epsilon doesn't belongs to L plus. Is it true or false? It is false. Why it is false? Because positive closure doesn't have epsilon, but the language L can have null values, epsilon. That's why it is not false. In the same way, epsilon belongs to L star. Is it true or false? Yes, it is true. And what will be the value of L star? We all know L star contain epsilon, but if we do complement of it, then epsilon doesn't come. So, and if it is, if we suppose L star complement will be equals to L complement star, is it true or false? It is false. Why it is false? Because we know that L star contain epsilon, but if we complement it, then epsilon will not be available there. So L complement star, because it is a star at the end, that's why it will contain epsilon. That's why they both will not equal. That's why it is false. And suppose we have L is equals to AB, BA, and epsilon is equals to AB. And then what will be the alphabet star? Alphabet star will be epsilon A, B, A, B, B, A, B, B, and so on. And what will be the L star? L star will be epsilon AB, BA, AB, AB, and so. So here we can clearly see that L star is a subset of alphabet star, because alphabet star contains all the values, but L star contains limited values. Some important terms are also there, that empty bracket will be equals to phi, and phi to the power 0 will be equals to epsilon. That's why epsilon is a subset of alphabet star, and phi is a subset of alphabet star, and epsilon is also a subset of alphabet star. And if we concatenate any language with identity, then the same language will come. If language is empty, then nothing is present. It will be empty. If we concatenate phi with language, then it will not equal to language. So if we concatenate phi with language, then it will be phi. And if we concatenate language with epsilon, then definitely it will be a language, because we all know language epsilon is present.